Hello, hi student. Today we will see about what are the technique through which we can change the property of semiconductor material. In last lecture we have seen that the semiconductor which has given us the permission and which allow us to change the property of material, okay, through which we can control, and we have the control over the flow of electron, and ultimately we have the control. We can change the direct magnitude of current, so therefore we can play with the device and it can generate a lot of applications. Now today we will see what are those techniques through which we can change the property of this semiconductor material. Okay, so let us see what are those technique technique through which we can change the property of what material, which material? Silicon or semiconductor material. So what are those property? First is what? Doping. Okay, so first is doping. Here what are those property? That is resistivity, conductivity and mobility. So what are this relation? If you see, this is R is equal to rho L by A, and here resistivity is nothing but 1 by sigma, and 1 by sigma is nothing but NQ mu N. So these are resistivity, conductivity and mobility, and this mobility of n-type semiconductor material. So these three are the property that we can change, and through which we have the control over the flow of electron. Okay, so number of electron, due to which we have the control over the current. We can vary the current, we can decrease the current, we can increase the current as per our requirement, and hence we can generate lot of application. So for this, the first technique is doping, and second technique is what? Temperature. Second technique is temperature, and due to temperature we can make the electron free from what? From semiconductor material, like from valence band to conduction band. Okay, so in third technique is what? Light. Eliminations of what? Light. Through the light we can also change the property of what? Material. Okay, so fourth technique is what? Silicon crystal, polysilicon crystal, single crystal and polysilicon crystal or amorphous, through which we can change the property of material, because crystal is nothing but it is a combinations of lattice plus base unit. What are the lattice? Lattice is nothing but where the atom are arranged in periodic manner, repeatedly in periodic manner. Okay, so actually if you see the lattice is nothing but it is a arrangement of some what number, arrangement of geometric array of point in the free space. Okay, so which has equal surrounding. Okay, in that place we can put one or more atom, and hence we can generate what? Crystal. Okay, so this is the basis plus lattice will give us crystal. So like in single crystal silicon, there is a perfect arrangement of an atom in periodic manner, and in polysilicon crystal there the arrangement is random, and in this way in amorphous material also the arrangement is different. Due to this arrangement we can change the property of material. So these are the four technique. Okay, so now we will see what are the other through which we can understand that more deeply that the semiconductor is different from how the semiconductor or electronic device is different from what electrical device. Okay, so now we will see how the electrical or how the electronic device is different from electrical device. See, electrical component here is electronic component. What? Electronic component. Okay, so electrical component, electronic component, and first if you see here resistor, and this is inductor, and this capacitor. This is capacitor, inductor, resistor, capacitor. Okay, so these are the what electrical component of electrical. These are the component of electrical and electronic component, like diode. Okay, so this is transistor, and this is MOSFET, and you can see here JFET. So this is what gate, source, drain, this is supply, and this is base, and collector, emitter, this is ground. Now we will see here what we can observe, what make the electronics different from electrical. First of all, we will see this is voltage that we have applied across the component, across the electrical device. So these are the voltage. Okay, so now if you see across the inductor, across the resistor, if you see across the resistor, what is the current through the resistor? What is the current? I is equal to V by R. What is I equal to V by R? Okay, so here what is the current through the diode? So its potential drop is VD positive. Okay, so its cut-in voltage, let us say it is 0.7 volt, it's VD, and it is ID. Okay, so now here current is ID. So here current is I, here current is ID, and this current is nothing but ID is equal to I naught into e to the power V by VD by eta VT minus 1. Okay, so this is the current through the diode, and this is the current through the resistor. Now we will see what beauty is there in this diode and what is in the resistor different by changing what polarity. Now we are going to change the polarity of this what voltage. Okay, so now if I will change this polarity of this what voltage, this is positive to negative. Now I am making this from negative to what positive, negative to what positive. So now we will see here the current, how much current is flowing through the what electrical component, this through the resistor is what minus V by R. If we see the magnitude wise, I is equal to how much? V by R. And actually before changing the polarity, the current magnitude of current is same. After changing the polarity, the magnitude of current is also same. Okay, so here we are not getting any change through the resistor after changing the polarity of voltage. If we see here, now come to here, now here the voltage, let us say here the voltage V positive negative that we have applied across this, diode. Okay, so V positive negative. So now this positive is connected to diode, negative is connected to positive is connected to p type material, and N negative is connected to N type material. So it is what in forward wise. So therefore